Hey there, welcome back. So in the previous couple of videos, we have seen, how you can create tensors, what kind of different operations you can do on top of tensors. And we have also seen some of the matrix operations on top of tensors. And in this video, we are finally going to see, why PyTorch tensors and NumPy ND-Arrays are interoperable, because we have been talking about NumPy and PyTorch interoperability from the very beginning. So let us finally check it out, right? So again, everything is written. I'm going to run it one by one and explain. So the first thing that we are going to do is, or I should say we are going to need, is the NumPy library. Now the NumPy library should by default be installed in this environment, since it came with Anaconda, and when we create a new environment, all the packages in the base environment, the default packages in the base environment should be copied over in the new environment. Now, but still, like, so I'll just execute it. Now for you, what might happen, that you'll see that this NumPy does not exist and all these things. So if you see that, then just go to Anaconda Navigator, and I'm in the environments tab now, and click on this green play button, open terminal, and here you can just pretty much run that I would write here python -m pip install NumPy. So if you do that, it will just install NumPy for you, and you can finally get started. Okay, now coming over here, so we have imported NumPy. Now first what I will do is I'll just create a very simple 3x4 tensor. So this is it. And now say you want the NumPy ND-array from this tensor. So you have a tensor, and now you want a 3x4 sized ND-array from this tensor. So how can you do that? You just call the tensor1.numpy function. So if I do it, I get an ND-array now. So you can see that here the type was a tensor, and here the type is an array, right? And this, with this single function, you can now understand why we are calling it interoperable. We have dedicated functions in PyTorch tensors using which you can convert them into NumPy ND-Arrays. So the integration at that level is existing in PyTorch. So now again, there is actually one function in the torch library using which you can check whether a given variable is a tensor or not. So here the function is called isTensor. So I'm just calling torch.isTensor, and here if I pass tensor1, you can see that the value is true, since tensor1 is a tensor. But if I pass NumPy array 1, it will return false, since this is a NumPy array. It's not a tensor, right? Now there is one thing that you should always remember, that the PyTorch tensors and the NumPy arrays you create from tensors and vice versa, now all of them contain the same memory. So basically, if you create a PyTorch tensor, then what happens is some part in the memory is blocked for that tensor, and in that part of memory the data is stored. Now when you create a NumPy array out of that tensor, then that NumPy array works just like a view. So when you create a NumPy array, no new memory location is created or something like that. You are still using the same memory location, and the NumPy array is just a view on top of the tensor. There is no physical NumPy array which exists some other place in your memory and so on. And just to demonstrate that, what we can do is we have the tensor1, which is this. So let us now add 10 to each of the elements in this tensor. And then what we will do is we'll just print the value of the NumPy array 1. So we'll add a value to tensor1, and we'll print the value of the NumPy array. And you can see that the NumPy array has also changed, right? So 10 is added to all the values in the NumPy array. Similarly, if you make any changes to the NumPy array, you will also see changes in the tensor. So here the first element, right, this element, we are changing it to 100 in the NumPy array, and then we are printing tensor1, and if we run it, we'll see that the tensor1 has also changed. So 100 is now the first element. So this is pretty much like one very important thing, that both of these tensors and NumPy arrays, they contain the same memory. So now coming to the different way. So previously what we did was we created a tensor out, we created an ND array out of a tensor. Now let us do the opposite thing. So we'll first create a NumPy array over here. This is a 2x3 NumPy array, and now we'll create a tensor out of it. So the way you do it is basically by calling the torch.fromNumPy function. So in the fromNumPy function, you just pass in the NumPy array that you have, and you'll pretty much get the tensor out of it. Now again, if you create it this way, the tensor and the NumPy are sharing the same memory location. So if you again call an in-memory operation and you pass in something, so here I'm calling the div function and I'm passing 10. So each of these elements will be divided by 10, and then I'm printing the NumPy array, the underlying NumPy array. So if I execute it, you will see that it has also changed, right? So I changed the tensor and the NumPy array got changed. So this is pretty much how tensors and NumPy work in an interoperable way. So you can see that in PyTorch there are dedicated function, like for each tensor you have the .numpy function, and you also have torch.fromNumPy for converting NumPy ND-Arrays into tensors. And this is pretty, these are some functions which make our life a lot easier, since what happens is, when you pre-process data, then you end up pre-processing mostly in NumPy, right? So you end up pre-processing in NumPy, and then when you are done with all the pre-processing, you just convert it into a tensor, and then you can feed that tensor directly to the neural network and so on. And like, these are a couple of functions which make that thing a lot easier for us. Yep, so that's it for this video. In the next video, we will see, we'll just talk about the GPU support that we have, or I should say the CUDA support that we have for PyTorch, and we'll also see a demo of that. So that's it, and I will see you in the next one.